Okay, as we get started on this lab, you'll see that I've got everything set up here. We've got our test tubes that are already labeled. I've gone ahead and set up the beakers of starch, cream, and pancreatin. I have my graduated cylinder, my beaker. I've already got my beaker heating up on the hot plate, and I have a few pieces of popcorn. We'll be using those for a couple of different things in this lab. And iodine, it's hard to see, but that's iodine. Blue litmus. We've also got Benedict's solution and our distilled water. So the first thing we need to do is go ahead and get our pancreatin poured into a test tube and get it heating on the hot plate. So we're going to pour 5 mils into the graduated cylinder and then transfer that to the tube that we've labeled BP for boiled pancreatin. There's 5 mils. And there's our BP. So I've pretty much already done steps 1 through 8 in our protocol. We need to wash our graduated cylinder, and in the magic of film editing, it's washed already. Okay, now we need the blue litmus, and we're going to add 20 milliliters to our beaker of cream. This graduated cylinder can only hold 10 mils, so we'll do this twice. Okay, and we've got that ready. Mix that up. Okay, so we're going to clean up a few things and wash our graduated cylinder. And it's all clean. We now need to set up our other test tubes. So I'm going to take a couple of pieces of popcorn here, and these we're just going to crumble up. And these are going to go in test tube A. So notice I'm just kind of breaking them up with my hands, not too small of pieces, but small enough to fairly easily fit into the test tube. This is a little bit of a messy lab. Okay, you can see there I've got lots of little pieces of popcorn. Okay, we'll clean up some of this mess. Okay, and now we need to add distilled water to test tube A. And there it is, 2 mils of water and a few pieces of popcorn. Okay, next we need to chew up some popcorn, and that'll go in test tube B. So I'm going to grab a few pieces here and chew that up. I'm spitting it into the tube off camera for your benefit. But if you were doing this in the lab, you'd get to watch each other spit in a tube. Okay, so I've added just a little bit of water, but lots of spit, so that you can now see that they look pretty much the same, although not quite as much in test tube B, but that's okay for what we're doing. Okay, I've wiped a few things down and cleaned our graduated cylinder. Now we're going to put our starch in test tubes C, D, and E. We need 5 mils of starch solution in each tube. We need to swirl it, make sure it's mixed well. And we'll go ahead and put 5 milliliters in each of those tubes. And it looks like our water's boiling, so I'm going to turn that down a little bit so it's not quite so hot. Alright, so there's our 5 mils. And make sure I get the right tubes here since I can't see the labels. And there's test tube C. And there's D. And we'll do that one more time. And test tube E. Okay, and you can see that those are all ready to go. Okay, and I've washed our graduated cylinder again. And now we're ready to take our cream and blue litmus mixture. And we're going to do the same thing. We're going to pour that into test tubes F, G, and H. You may notice that I'm using 5 mils instead of 10 in the tubes. It doesn't really make any difference in this lab. What we're really doing is looking for color changes indicating the activity of enzymes. So you may want to make a note of that in your protocol that in this demonstration we're using 5 mils. The end result will be the same. Okay, there they are. Okay, and we need to clean our glassware. And we're going to add pancreatin, either boiled or the normal pancreatin, or water to our tubes. So the experimental variable here is going to be pancreatin. Our control is water. We actually have 2 experimental variables because we're looking at both boiled and unboiled pancreatin. So here we're adding 2 mils to test tube C. That's the unboiled pancreatin. Okay, and we're going to do the same thing and add that to test tube F. Again, this is unboiled pancreatin. Okay, I've done a little cleanup and rinsed out our graduated cylinder, and we're going to do the same thing. We're going to add 2 milliliters of boiled pancreatin to test tubes D and G. So there's our boiled pancreatin. This is to test the effect of temperature on the activity of enzymes. Okay, there's our 2 mils, and I'll add that to test tube D. And we'll measure out 2 more mils and add that to test tube G. Okay, we've got that in there. And I need to go wash our graduated cylinder. And the last thing that we need to do is add our water to the remaining tubes. And remember, our water is the control because we don't expect it to do anything. So 2 mils in E and 2 mils of water in H. Alright, and our test tubes are now all set up. But before we go on, let's recap for a minute. Remember, test tubes A and B contain popcorn. A is popcorn and water. B is popcorn and saliva. C, D, and E are starch solutions with pancreatin, boiled pancreatin, and water. And F, G, and H are the same thing except with the cream blue litmus solution. And you can see they're all set up, ready to go. And we're going to head off to the water bath. Here's the water bath. Our tubes are already set up. The tops are sticking up out of the water, and they'll sit there at 45 degrees for 45 minutes. Okay, while we're waiting those 45 minutes, we're going to practice with the indicators that we are using in this lab so that you become comfortable using them and you know what they're used for and what a positive and negative result looks like. Okay, I've got my test tubes labeled S1, S2, D1, D2, B1, B2 as indicated in the protocol. S for starch, D for dextrose, and B for blue litmus. So I'm going to go ahead and add a little bit. It doesn't really matter how much we add, but I'm going to add a little bit of starch to the two S tubes. Quantities here don't really matter because what we're looking for is just that color change that indicates a positive or a negative. It doesn't take much to get a good result, so just a little pinch. Okay, there's our starch. Clean that off. Okay, we're going to add dextrose, which is a simple sugar, to D1 and D2. Okay, and we're going to add blue litmus to the last two tubes. Blue litmus is itself the indicator. Okay, I've measured out 10 milliliters. We're going to put 5 milliliters in each of the tubes. So I'll go ahead and put 5 in the first one, and then the rest in the second one. And as we're doing that, blue litmus is really not so much blue as it is purple. It's kind of a dark, dark purple. So sometimes people get Benedict solution confused with blue litmus, and I would encourage you to pay attention here because if you are tested on these reagents, you'll want to know which ones are which. Benedict solution is bright blue. Blue litmus is dark purple. Not very intuitive. Alright, so we've got our tubes set up. We need to add some water to test tubes S1, S2, D1, and D2. So again, I'm filling it to 10 milliliters. We'll put 5 milliliters in each of the first two tubes, and then we'll do the same thing with the second two tubes so that we have a starch solution and a dextrose solution. Okay, we've got our 5 milliliters in each of those tubes. We'll do the same thing for the dextrose. Let's shake those up a little bit, make sure they're mixed real well. You can see that they're cloudy. Starch makes a cloudy solution. Alright, so the same thing. We need 10 milliliters. And we'll put 5 in each. And again, we'll shake them up a little bit, make sure they mix. Simple sugars are much smaller molecules, so it makes a clear solution. Okay, and we've got our blue litmus ready. Now what we're doing is just testing them with the different indicators to see what they look like, and so that we can see what a positive and a negative look like. Now, Benedict solution, hopefully you know this already, Benedict solution is blue. A positive result with Benedict solution is orange, and it tests for simple sugars. We're going to add that to both of the carbohydrates that we have here. Starch is a carbohydrate, dextrose is a carbohydrate, but starch is a complex sugar. Large molecule makes a cloudy solution. Dextrose is a simple sugar. So we'll go ahead and add our Benedict solution to S1 and to D1. Okay. Now make sure we put it in the right one. Okay, we're putting that in D1. And we've turned the solutions blue. Is that a positive indication? Well, no, because Benedict's solution is already blue. What we're looking for is orange. So we're going to set those in a beaker of boiling water because Benedict's will not work without being heated to boiling. All right, now we're going to look at our blue litmus, and we've got a little bit of acid here. This is a 0.1 molar HCl solution, and I want to show you what that looks like if we add that to one of the tubes to see what happens when we have an acid present when mixed with blue litmus. Blue litmus is normally that kind of a dark purple color, and it's kind of hard to see, but maybe a little bit with my white lab coat behind it, you can see that B1 turned much more red colored. Okay, if we go back to our first D1 and S1 tubes, you can see already just in that short period of time we've got a color change in D1. We do not have a color change in S1. So what does that tell you? That tells you that Benedict's solution in the presence of simple sugars turns orange. In the presence of complex sugars or complex carbohydrates, it stays blue. That would be negative. So here I'm going to add a little bit more acid just to see if we can get that result a little bit more. There we go. We can see that real easily now. So a few more drops. We can see that that purple solution just turned kind of a reddish, pinkish color. And if you hold them up side by side, it's pretty obvious at this point. So blue litmus tests for acid, and the more acidic it is, the more red it becomes rather than purple. Okay, here's our iodine. Iodine tests for complex carbohydrates. Iodine is already orange, just to confuse things a little bit more. Notice when we add it to the starch solution, the S2 tube, it turns black. So obviously that's a positive result with starch and iodine, a negative result with starch and Benedict's. Okay, let's try this with simple sugars. Remember, simple sugars and Benedict's gave a positive result. If we add iodine to simple sugars, well, iodine's orange, it just turns the solution orange. That's not really a positive change. So notice the D1 is a positive test for Benedict's and simple sugar. D2 is a negative result for iodine and simple sugar. All right, let's try this with a piece of popcorn. Popcorn is very starchy, and we'll see that by just adding a couple of drops of iodine to it. What happens when you add iodine? It turns the popcorn black. I mean, absolutely black. It looks like somebody just put black ink on it. And that would be a positive indication for starch in popcorn. And popcorn is mostly starch. Okay, I've gotten our tubes A through H out. They incubated for 45 minutes. We're now going to test them with Benedict solution, or at least we're going to test most of them. And just like we did before, we're going to add 5 mils of Benedict reagent or Benedict solution to tubes A through E. Now you may be wondering, why are we going to do that? Remember that what we've done is use pancreatin as our experimental variable, and pancreatin contains enzymes that will break down complex molecules like starch into sugars, simple sugars, like dextrose. And what we want to do is find out which tubes show that the starch was broken down into simple sugars. And after demonstrating how this indicator works, we should be able to add the Benedict solution, and of course Benedict's always needs to be heated up, so we'll have to put those tubes in the boiling water, and then we'll see a color change in those tubes that have had some digestion or breakdown of the starch molecules into simple sugars. Now, hopefully you can predict which of these tubes will have simple sugars present. We'll find out in just a moment, and see if you can figure out why we get those results. Okay, so we've got Benedict solution in A, B, C, D, E. We don't need to add it to F, G, and H because that was testing for the breakdown of the fats in the cream. Okay, so let's take a look at those tubes. They are pretty much instantaneous. G and H look a little different than F. And if you look at F, you can see it's a little bit more of a red color. What does that indicate? Well, that would indicate the presence of acids. So what was in F? F had pancreatin that was not boiled, and cream and blue litmus. In G, we added boiled pancreatin to our cream and blue litmus, and in H, we just added water. Okay, so let's finish this up. We've waited a couple more minutes to heat up our Benedict solution and test tubes, and you can see that we're starting to see some color changes there. There's A, had water and popcorn. There's B, had saliva and popcorn. No pancreatin though. So what was that saliva doing? There's C. C had the starch and pancreatin and Benedict solution. D had starch and boiled pancreatin and Benedict solution. Notice it's a little green colored. E just had water, starch, and no pancreatin and Benedict solution. And then we already talked about these F, G, and H. F turned pink, G and H didn't. Make sure you understand what all this means and write your conclusions in your lab manual. You will be expected to know the purpose of the indicators and what positives and negatives look like, and also be able to explain why we got the results we did and what each of these tests indicated happened in the presence of either boiled or unboiled pancreatin. And that's it.